To sketch this graph, again, we always start by factoring. The bottom here can be factored x plus 5, x minus 5. First thing we always look for, vertical asymptotes and holes based on our non-permissible values. Well, x can't equal 5 and x can't equal negative 5. Both of these will be vertical asymptotes. A slight thing for notation, when we state non-permissible values, we write a line through the equal sign to say that it can't equal 5, can't equal negative 5. When we write the equations of vertical asymptotes, when we put them on we always write an equation of an asymptote has an equal sign. There's never a slash through that equal sign because you're actually writing an equation down. So non-permissible values have the line through. Asymptotes are an equation with an equal sign. Step number 1. Step number 2. Look at the highest power. The highest power in this one is an x squared. We have negative 2x squareds in our numerator. We have 1x squared in our denominator. This simplifies to negative 2, so we will have a horizontal asymptote at y equals negative 2. Y-intercept, plug in 0 for x. You get y equals 0. Anytime your y-intercept is 0, that means your x-intercept will also be 0. Looking at this equation, looking at the numerator here in red, you can see that that's the only place that you'll have an x-intercept. The only thing that will make that in the red box equal to 0 is if x is 0. Now we should have enough information to start our graph, maybe even finish our graph. So we had asymptotes at negative 5, 5, and y equals negative 2. So notice when I write these equations, I have an equal sign. I don't put a slash through those equal signs. We have one x-intercept, one y-intercept at 0, 0. We really don't have enough information here at all to tell us anything about the graph yet. So this is where, when we had our notes before, we might have to plug in some other points, and we might have to check the asymptotic behavior. So first of all, let's do this outside section. Notice that our vertical asymptotes separate this into 3 sections. I'll call this section 1, the middle section 2, and this section over here. So you see how those vertical asymptotes separate your x values into different sections. In this case, 3 different sections. If I wanted to find a point in section number 1, what's an x value I could plug in? Negative 6. And usually we like to go close. Like if you tried negative 100, that would be fine too, but it's like way off your graph. So negative 6, if I go to my equation and I plug in negative 6, I'm going to get some big numbers here, but that's okay. I'm going to get on the top. Negative 6 squared is 36 times a negative 2 is going to be negative 72. Negative 6 on the bottom, this is going to be negative 1. This is going to be negative 11. Between what numbers, if I simplify this, do you see that I'm going to get negative 72 over 11? Between what whole numbers will that be? Or what integers? 6 and 7. Because 66 divided by 11 is 6, 77 divided by 11 is 7. We know that this is between 6 and 7. So when I go to graph this, 3, 4, 5, 6, 7, I can put this point on right here, negative 6, negative 72 over 11, approximately there. Once I have that point, asymptotic behavior, this section will look like this. We will also have that same point with positive 6. How do I know that? Can you see if I look back at my original equation here, I just have x squareds. Can you see if you square 6 or if you square negative 6, you'll get 36. It won't make a difference. So a little bit of noticing something about my equation which allowed me to do this section a little bit quicker. If you don't recognize that and plug in positive 6, it's not really going to take you that much more time, but you'll find you'll get negative 72 over 11 there as well. So now we have to figure out a little bit of what is happening in our middle section as we get close to those asymptotes. So let's do the positive one first. As I get close to 5, should I plug in 4.9 or 5.1? If I want to find out this middle section, what's happening when we get close to x equals 5? We want to plug in 4.9 because we're coming towards 5 from the left, so positive 4.9. Checking that with my equation. Can you see that no matter what I plug into the top of my equation is going to be negative? 4.9 squared is positive. Anything squared is positive. Times a negative 2 will always be negative. If I plug in 4.9 into this section, can you see that I'll get a positive number? When I plug in 4.9 into this section, can you see that I will get a negative number? All of those things put together end with a positive value. So if I have a positive value there as I approach 4.9, I know that my graph is going to be going up towards that value. What number am I going to check for the other asymptotic behavior as I get close to negative 5? Negative 5.1 or negative 4.9? Negative 4.9. Again, I'll erase this black value and that one. The top is still going to be negative. If I plug in negative 4.9, can you see that this is still going to be positive? And negative 4.9 into here will still be negative. That whole thing put together again will give us a positive value. So as we go down, we know on this side as well, it goes to the positive values. Okay, question number 4 to practice for later.